In this lecture, I'm going to discuss why do carboxylic acids produce H+1 ions. There's a question that since all the bonds in a carboxylic acid are covalent bonds, so why do they ionize and why do they end up forming ions? Now I've drawn carboxylic acid. This is ethanoic acid, and this over here is the carboxylic acid functional group that I've drawn over here, which is that it has a C double bond O and it is bonded to a hydroxy group, which is the OH group over here. Now, carboxylic acids don't produce H+1 ions on their own. Generally, they do that when they are in aqueous state. Now, in aqueous state, what that means is that there is a water molecule involved. They dissolve in water. So, what happens when water molecules and carboxylic acids interact? What happens is that oxygen is very electronegative. So, there's an oxygen atom over here, and what electronegative means is that it has a tendency to attract the shared pair of electrons towards itself. So if there is a shared covalent bond between O and H, and there's a shared pair of electrons, then oxygen over here would have a very high tendency to attract these electrons towards itself. So as it attracts these electrons towards itself, this oxygen over here is going to get a slight negative charge, because the electrons over here in the bond between O and H, these electrons would be lying closer to oxygen, and they would be further away from hydrogen. So hydrogen would have a slight positive charge. So this means that the OH bond is a polar covalent bond. The electrons are not evenly shared. They're lying slightly closer to oxygen, because oxygen is more electronegative. And if you revise the concepts of electronegativity, you would realize that the elements that are on the extreme right and at the top of the periodic table, these are the elements that are more electronegative because they're smaller. Their nucleus is more exposed, so they would have a very high tendency to attract electrons. So it's a polar covalent bond. The electrons are lying closer to oxygen. And the same applies to this water molecule over here. Hydrogen is very electropositive, so the shared pair of electrons between oxygen and hydrogen would be lying closer to oxygen. So these electrons would be slightly closer to oxygen. Hence, this bond would also be polar, and oxygen would have a slight negative charge and hydrogen would have a slight positive charge. When this happens, since both molecules are polar covalent molecules, when this happens, what happens is that this oxygen has a slight negative charge, and it has these lone pairs as well, which are completely full outer orbitals. So these electrons over here, they're going to attract this positive hydrogen. So as the electrons are attracted, so let's show this with this orange arrow. These electrons would be attracted by the positive hydrogen, or vice versa, the positive hydrogen would be attracted to the lone pair of electrons on the oxygen atom in the water molecule. So as these electrons are attracted, the electrons over here will be repelled because of the negative charge that's coming from this side. So this negative charge is going to repel further the electrons that were shared, and these electrons are going to get repelled and they would be lying closer to oxygen. What this would eventually do is it's going to break this bond over here, because the positive hydrogen would be attracted by these electrons. So the force of attraction of these electrons and this positive hydrogen would be stronger. So this hydrogen over here would be attracted by the electrons over here, and the electrons in the shared covalent bond would be repelled because of the negative charge coming from this side, and it would go towards oxygen. So in the next step, what happens is that an ethanoate ion is produced, where the shared electrons are now lying with oxygen, and oxygen gets a negative charge, and oxygen ends up forming a negative ion. So this is called heterolytic fission. This OH bond broke into two parts heterolytically, with the electrons, the shared electrons, going towards oxygen. And what happens with the hydrogen on the other side? What happens with hydrogen on the other side is that the water molecule, which had these lone pairs, ended up forming a dative covalent bond. So let's show that dative covalent bond with a red arrow. So a dative covalent bond, that positive hydrogen would be attracted by the lone pairs on the oxygen, and a molecule of H3O plus would be formed. So this molecule, which is H3O plus, is then formed. So this is the other ion that is formed. This is called a hydronium ion, and generally whenever we talk about H plus 1 ions, what we are basically talking about are these H3O plus ions. So as a simplification, this is what we call H plus 1 ions in chemistry. So this is how a carboxylic acid like ethanoic acid ends up losing H plus 1 ions when it is dissolved in water.